All right, everyone, welcome. This is homework number 4 for chapter 5. Let's get going. Number 77. Avery and Colin were trying to challenge each other with equations for sequences. Avery was looking at an explicit equation that Colin wrote. Okay, the one that Colin wrote is t of n equals 4.5n minus 8. All right, first, write the first four terms for the sequence. All right, so the first one, so the first term is when you put 1 in there. So pull your calculator. Okay, I got it on the side. Here, let me pull it out. Oop. Oop. Okay, whatever. Go away. All right, so pull out your calculator. Okay, I'm gonna pull it out right here. So I'm gonna go 4.5 times 1 and then minus 8. That gets me negative 3.5. So my first term is when I put 1 in there and I get negative 3.5. So my first term I get negative 3.5. My second term is when I put 2 in there. So my equation, or my Avery's explicit equation, I'm going to go ahead and put 2 in there. Right? And in my calculator, I just do that, but I just copy 4.5 times 2, just like that. And you can use your calculator, and it can keep getting the answer for you. I'm just going to keep going because I know I have to do 4, so I'm going to go and do the next one. 4.5 times 3. That's my third term. You see how it looks exactly the same? So my next term is 1. My next term is 5.5. And my last term, my fourth term, is 10. So negative 3.5, 1, 5.5, and 10. So next term is 1, 5.5, and 10. Right? So that's my first term, second term, third term, and fourth term. Right? So that's how you do it. Okay, what would Avery do to write the 15th term in his sequence? So in order to write the 15th term in his sequence, because this is an explicit equation, you can just go straight to the 15th term. You don't need to find out, what number 14 is to write down the 15th term. You don't have to do that because it's explicit. You can go straight to the 15th term, meaning you can just plug in the 15 into n. So what would Avery do to write the 15th term in the sequence? Okay, Avery would have to substitute 15 in for the n. Write a recursive equation for the sequence. All right, now in order to write a recursive, we have to know what's going on. And what's going on is we basically, this right here tells you, okay, that we're going to add 4.5 every single time. And if you look here, first term to this term is we're going to add 4.5. Number 1 to, or from 1 to 5.5, we're adding 4.5. 5.5 to 10, we're adding 4.5, right? So we have to know what's going on, and all we have to do to write recursive is we have to write the first term. So we'll say t of 1 equals negative 3.5. Then to write the rest of them, we just have to write t of n. Oops, sorry, that was n plus 1, meaning I want the next one, right? So that's what recursive means. Recursive means I want the next one after what I have. So t of n plus 1 equals t of n plus 4.5, and that's how I get to the next one and the next one, next one. Okay, so to get to the next one, I have to look at the one in front of that, and I have to add 4.5. So that's basically what it's saying. Okay. Okay, number 8. Write both an explicit equation and recursive equation for the sequence. So whether you're doing recursive or explicit, you need to know what the heck is going on between 5 to 8, between 8 to 11, 11 to 14, 14 to 17. You need to know what the pattern is. Looks like 5 to 8, you're adding 3. And 8 to 11 looks like, you know what, you're also adding 3. 11 to 14, you're adding 3. 14 to 17, you're adding 3. So it looks like the pattern is adding 3. So our D is positive 3. Okay, and will need that number for both the recursive and the explicit. Okay, so let's write an explicit. Okay, explicit is T of n equals, and then the D, so it'll be 3n plus, and then whatever the 0th term is. So, you know, if I'm adding 3 to get, and 5 is my first number, I need to go backwards. So I'll use light blue. So if I go backwards, to get my 0th term, I'll be subtracting 3. So 5 minus 3, this will give me 2. So my 0th term is 2. So that means that it's going to be 3n plus 2, right? And we can check it out, right? So look, this is my first term, second term, third term, fourth term, fifth term. That's my 0th term. Remember, we just found that. But if I wanted to find out my fifth term, just to check it out, I'm going to put in 5. So if I put 5 in here, that's 3 times 5 is 15, and then plus 2. That makes 17, and see how it works out? So this is my explicit formula, or my explicit equation. My recursive, okay, I'm put that in red. Recursive needs to start with a number, because yes, we would need to utilize that D equals 3, but we need to know where to start, because you can start at 3, or you can start at negative 27, right? But we need to say, okay, well, we're going to start with the first term is 5. So recursive starts with T of 1 equals 5. And then we build from that. So we'll say T of n plus 1, meaning one more is going to be our D. So it'll be, it'll be our previous term. So the previous term from n plus 1 is going to be T of n, and then you're going to add 3 to it, because that's what's happening. Okay, and that's our recursive, and we can check it out again if we want to know. So remember, recursive, we can't just jump to the, I'll use orange. Recursive, we can't just jump to the fifth term, okay? Because look, if we put 5 in here, right? So let me erase that. Let me just put a, well, actually, I'll make it fit. So if I put 5 right here, that'll be 5 plus 1, which means we're actually, and sorry, if I put 5 there and 5 here, which means that if I put 5 in there, which means I will actually be looking for the T. 5 plus 1 is 6. So that means I'll be looking for the 6th term. And the 6th term is equal to the 5th term, but I need to know what the 5th term is, which is 17. So if I want to know the 5th term, I actually need to look at the 4th term. And if I need to know the 4th term, I need to look at the 3rd term, and so forth and so forth. So I actually can't go to any one number that I need. If I wanted the 5th term, I have to go to the 1st term. The 1st term is right here. Then I have to go to the 2nd term. But so to get the 2nd term, I'm going to go ahead and I'm going to use green. So to get my 2nd term, I have to use 1 for n equals 1, and 1 right here, because the n's the same thing. So let's check out what this says. This says T of 1 plus 1 is 2, which is my 2nd term. That's going to equal T of 1, which we know already. T of 1 is 5, so 5, now plus 3. So T of 2 equals 8. Okay, and now that we know T of 1 and T of 2, we can do T of 3. And T of 3 is when we put into our original equation. Right, move that, get rid of that 1. All right, T of 3 is when we put 2 into our equation. So because we know the 2nd term, T2, now that we know 2nd term, we can put 2 in here. And we put 2 in there, it'll be 2 plus 1, so it'll actually be T3. So it'll be T, remember 2 plus 1 is 3, so we get it from here, 2 plus 1 is 3. So we get T3, is equal to, then be T2, which is actually, so right here, T2, which is actually 8. So it'd be 8 plus 3. All right, so now we know what T3 is, which is 11. And you see how the third one matches. So in order to get the fifth one, we got to keep going on and on and on. Okay, so recursive doesn't actually show you any term you want. You have to kind of make the whole list if you want to know what the fifth one is, because you have to get the first one, which is 5, and then from there you can get the second one, which is 8, and then from there you can get the third one, which is 11, and so forth and so forth. So if you want any of those, you have to be able to just get the first one and the recursive pattern, the recursive formula, which is t of n plus 1 equals t of n plus 3. That's the recursive formula. This is 3n plus 2 is the explicit equation. So explicit, t of n equals 3n plus 2. Recursive, t of 1 equals 5, and then t of n plus 1 is equal to t of n plus 3. Excuse me. Last one. Compute the following products. Okay, this is just a little practice from previous chapter. So this one right here, we can do it with an area model. This is 4x plus 5 and 4x minus 5. Okay, and this makes 4 times 4 is 16. X times x is x squared. There's two of those. Okay, and we're multiplying it, so they double up. Okay, 4x, so we're working on this one right here, which is going to involve the 4x and the 5. So 4 times 5 is 20. And there's only one x, so we just write down an x. Okay, same thing again. We want this one, which is going to involve the negative 5 and the 4x. So negative 5 and 4 makes negative 20. And it has only one x, so we just write down an x. Okay, and we want this one right here, which is going to involve this side, which is actually that side, which is actually this length, and we also want this side, which in this case is the same as this. So we want negative 5 times 5, which is negative 20. Sorry, you know me, I'm a little particular about my colors, so negative 25. All right. So now I can, to finish it off, I'm going to add the like term, which is going to be just these two. These are both x's, so I can add them together, which makes 0. So my final answer, 16x squared, and negative 20x and 20x makes 0x or no x's, and then minus 25. Okay, that's your final answer. You want to write it a little better, it could be 16x squared and then minus 25. You don't need to put the 0x. Okay, this one right here, we'll go with green. This one is 4x plus 5 and 4x plus 5. Okay, if I want this stuff that's in here, okay, it's going to require me to utilize this length and this width, right? And the length is 4x and the width is 4x. So 4x times 4, or first of all, 4 times 4 is 16. Sorry. 4 times 4 is 16. And x times x is x squared. There's two of those x's. Okay. If I want this next piece right there, I need to utilize the length and the width. And the length is 5, but the width is this right here. But then it comes, you see, it measures out 4x. So we need to go 4x times 5. So first, 4 times 5 is 20. And then there's only one x, so we're going to put an x there. This right here, this is the length of that times the width of that. So that's 5. The length is up here, but then we'll see that it's the same as that length right there, which is the 4x. So 4x times 5. And again, it's the same scenario. It's 4 times 5 is 20. And then x is just x because they between both of those, they only have one of the x. Okay, this one right here, we want the width times the length. Okay, the width is 5, the length is 5, so 5 times 5, oops, wrong one. 5 times 5, just dragging the wrong one. 5 times 5 is 25. So my answer is 25. So finale, okay, let's see. 16x squared. So basically, I need to put all the x squares together, and that's the only thing I got. So that's the only thing I have with x squared. So we get 16x squared. Okay. 20x, and then is there any other x's that we have? Yes, there is another x, which is this one right here. So another x, which is actually happens to be 20 also. So 20 plus 20, or 20x's plus 20x is 40x. Okay, not x squared because we're not multiplying it. So 20x plus 20x is 40x. Okay, it's like you got 20 sodas and you're going to add 20 sodas. You get 40 sodas. You don't get 40 sodas squared. Right? And then lastly, do we have anything that just has numbers? Well, the only thing we got is just 25, and that's the only thing that has just numbers. So we're going to go plus 25. That's our final answer. That's your final answer. All right. That's a wrap. I'll see you guys